This is Teacher Abby, and for today's video, we're going to talk about arithmetic sequence. And for our lesson's objectives, we need to illustrate an arithmetic sequence. Specifically, state whether the given sequence is an arithmetic sequence or not. Define arithmetic sequence. Derive arithmetic sequence and solves arithmetic sequence. Before we proceed with our discussion, let's have first a simple drill. So this drill is what you call what's the pattern. So you're going to look for the pattern of the given sequences. For number 1, we have the sequence 2, 4, 6, 8. What is the pattern? As you notice, the pattern is we just add 2 to get the next term. Now, for the second sequence, we have 3, 6, 12, and 24. What's the pattern? The pattern is we just multiply 2 to get the next term. For number 3, we have the sequence 5, 10, 15, and 20. What is the pattern? As you notice, we just add 5 to get the next pattern, or term, rather. For number 4 sequence, we have negative 2, negative 6, negative 10, and negative 14. The pattern is we just simply add negative 4 to get the next term. Did you get it? So as you notice, on the first, third, and fourth sequence, we have the same patterns. We just add a number to get the next term, which is relevant for our today's lesson. And our lesson for today will focus on one of the first type of sequence, which is what you called arithmetic sequence. By definition, arithmetic sequence is a sequence in which term after the first is formed by adding a fixed number to the preceding term. Its formula is a sub n is equal to a sub 1 plus n minus 1 multiplied by d, wherein our a sub n is the nth term, our a sub 1 is the first term, n is the number of terms, and d is the common difference. On the other hand, our common difference, which is d, is the constant number added to the preceding term of the arithmetic sequence. It can be calculated by subtracting any two consecutive terms in the arithmetic sequence. Let us have an example. So in this sequence, we have 2, 7, 12, 17, and 22. And we all know that 2 will be our a sub 1 or first term, 7 is our a sub 2 or second term, 12 is our a sub 3 or third term, and 17 is our a sub 4 or fourth term, and 22 is our a sub 5 or the fifth term. So we need to get first the common difference. How do we get that? We simply subtract two consecutive terms. Let us say We subtract 7 and 2. So that will be 5 because 7 minus 2 is 5. So let us try another more. Let us say we try to subtract 12 and 7. 12 minus 7 is equal to 5. 17 minus 12 is equal to 5 also. And 22 minus 17 is also 5. So as you notice, our difference is constant. Therefore, our common difference is 5. And since we have a common difference which is 5, we can say that this sequence, the sequence 2, 7, 12, 17, and 22 is an arithmetic sequence. Okay? And now, let's have an example. Determine if the sequence is arithmetic or not. If it is, find the common difference and the next 3 terms of the sequence. So here we have a sequence which is negative 4, 3, 10, and 17. So the first thing that we need to do is check first if there is common difference. So remember, this is your a sub 1, first term. This is your a sub 2 or second term. This is your a sub 3 or the third term. And this is your a sub 4, which is the fourth term. Now, our common difference is being solved by subtracting 2 consecutive terms. So let us try first the a sub 2 minus a sub 1. That will be 3 minus negative 4. And the answer will be 7. Let's try another more. So let's have the third term and the second term. So that will be a sub 3 minus a sub 2. That will be 10 minus 3, which is equal to 7. And lastly, let's try the fourth term minus the third term, which is 17 minus 10 is also equal to 7. So as you notice, we have a common difference which is equal to 7. And since we have a common difference which is equal to 7, therefore this sequence, the negative 4, 3, 10, and 17 is an arithmetic sequence. Okay? Now, let us find the next 3 terms of the sequence. Since our common difference is 7, we just simply add 7 to get the next term. So let us try. 17 plus 7, that will be, okay, 24. Then, 24 plus 7, that is 31, and 31 plus 7 is equal to 38. So therefore, the next 3 terms of this sequence is 24, 31, and 38. Let us have a working activity. So this activity is called Let's Identify. The instruction is identify if the sequence is arithmetic sequence or not. If it is, find the common difference and the next 3 terms of the sequence. For our given, we have number 1, 1, 2, 3, 4, 5, 6, 7, and 8. For number 2, 2, 5, 8, 11, 14, 17, and 20. For number 3, we have 1, 4, 16, 64, 256, 1024, and 4096. And for number 4, we have 5, 10, 15, 20, 25, 30, 35. Okay? So the first thing that we need to do is we should get first the common difference. Because if there is common difference, we can able to identify if it is an arithmetic sequence or not. So based on this, through inspection, 2 minus 1, that is 1. 3 minus 2, that is also 1. 4 minus 3 is also 1. 5 minus 4 is also 1. And so on and so forth. So all of the differences is equal to 1. Therefore, our common difference is D is equal to 1. Since we have a common difference which is equal to 1, we can say that the sequence in number 1 is an arithmetic sequence. And for us to able to get the next 3 terms of this sequence, we just simply add the common difference. So, we're going to add 8 plus 1, that is 9. Then 9 plus 1, that is 10. And 10 plus 1, that is equal to 11. So, the next 3 terms of this sequence is 9, 10, and 11. Is it clear? Okay, now, for number 2, let us get first if there is a common difference. So, we subtract the preceding term by the previous term, which is 5 minus 2, that is 3. 8 minus 5, that is also 3. 11 minus 8, that is also 3. And 14 minus 11 is also 3. So, as you get the common difference by the preceding term, it's also 3. So, therefore, the common difference is 3. Since we have the common difference, which is 3, this is an arithmetic sequence. And to get the next terms of the sequence, we simply add the common difference, which is 3. So, 20 plus 3, which is 23. Then, 23 plus 3, that is 26. And 26 plus 3, that is 29. So, the next 3 terms for this sequence is 23, 26, and 29. Okay? For number 3, you have the sequence 1, 4, 16, 64, 256, 1024, and 4096. Let us try first if it has an what you call common difference. So, subtracting 4 minus 6, that is 3. 16 minus 4 is equal to 12. So, as you notice, based on the 3 first terms that are being subtracted, there is already a different value of differences. So, therefore, we don't have any common difference. And since we have no common difference, we can say that this is not an arithmetic sequence. Okay? For number 4, let's get the common difference first. So, we have 10 minus 5, that is 5. 15 minus 10, that is also 5. 20 minus 15, that is also 5. 25 minus 20, that is also 5. So, as you notice, the value of our common difference is equal to 5. And since we have a common difference, this is what you call arithmetic sequence. And the 3 next terms for this sequence is 35, since we ended up with 35. So, 35 plus 5, that is 40. Then, 40 plus 5, that is 45. Then, 45 plus 5, that is 50. So, the next 3 terms of this sequence is 40, 45, and 50. Okay? Let's have more examples. Okay. So, By pattern searching, identify the 10th term of the following. So we have 2, 5, 8, 11, 14, 17, and 20. First, we get the value of our common difference. 5 subtracted by 2, that is 3. 8 minus 5 is also 3. 11 minus 8 is also 3. Therefore, our common difference is 3, and it is obtained by subtracting the second term by the first term and third term by the second term, and so on. Now, since the common difference is 3, we simply add 3 to the preceding term in order for us to get the next terms. So, in the given, we already have 7 terms. So, we're looking for the 10th term. So, we add 3 more terms. So, 20 plus 3, that is 23. And 23 plus 3, that is 26. And 26 plus 3 is 29. So, therefore, our 10th term is 29. Okay? So, what if we're looking for large number of terms? For example, we're looking for 100 term. Is this pattern searching is still applicable? Definitely not, because it will consume a lot of time for us to solve for the missing term. Okay? And now, let us identify or find the a sub 10 or the 10th term of the sequence 2, 5, 8, 11, 14, 17, and 20. As you notice, this sequence is being used a while ago for our example, but we use pattern searching in order for us to get the 10th term. For this example, we're going to use the formula of the arithmetic sequence. Okay? So, the first thing that we need to do is find the common difference. So, a sub 2 minus a sub 1, that will be 5 minus 2. Then a sub 3 minus a sub 2, that is 8 minus 5. Then a sub 4 minus a sub 3, that is 11 minus 8, which is all equal to 3. Now, our formula is for getting the values of an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 multiplied by d. Remember that our a sub n is the last term, or the nth term rather. A sub 1 is the first term. Our n is the number of terms, and the d is the common difference. Now, let us get the values of the given. Okay? For our a sub 1, we have 2. Since the first term is 2. Our n is equal to 10. Since we're looking for the a sub 10. This means this is the 10th term. Okay? Next, our d is 3. Coming from here. The common difference. And our a sub 10 is the missing term or the 10th term. So, using the formula, we're going to substitute the givens. So, that will be a sub 10 equal to 2 plus 10 minus 1 multiplied by 3. So, the first thing that we need to simplify in this case is the ones that are inside the parentheses. So, that is 10 minus 1. So, 10 minus 1 is 9. Then, we should multiply 9 times 3, that is 27. Then, copy 2. Then, 2 plus 27 is 29. So as you notice, we have the same answers from the example a while ago through pattern searching. So using a formula of the arithmetic sequence is much more easier to use, especially if we're looking for a large number of terms. Okay? Let's have more examples. So for example number 2, find the a sub 40 or the 40th term of the sequence 9, 15, 21, and 27. So again, let us first get the value of our common difference. So a sub 2 minus a sub 1, that is 15 minus 9. Then a sub 3 minus a sub 2, that is 21 minus 15. Then a sub 4 minus a sub 3, that is 27 minus 21, which is all equal to 6. So our common difference there is 6. And using again the formula, a sub n is equal to a sub 1 plus n minus 1 multiplied by d. Let's get the given. Our a sub 1 or the first term is 9. Then our n is equal to 40 since we're looking for the a sub 40 or the 40th term. Our d is equal to 6 since our common difference is also equal to 6. And we're looking for a sub 40. So, substituting the values from the given, that will be a sub 40 is equal to 9 plus 40 minus 1 multiplied by 6. Then, simplify 40 minus 1, that is 39. And 39 times 6 is equal to 234. Then, 234 plus 9, that is equal to 243. So, our a sub 40 or the 40th term rather is equal to 243. Okay? Okay, so for our third example, we need to find a sub 35 or the 35th term of the sequence negative 4, negative 16, negative 28, and negative 40. Let us find first the common difference. That will be a sub 2 minus a sub 1, which is negative 16 minus negative 4. Then a sub 3 minus a sub 2, that is negative 28 minus negative 16. Then a sub 4 minus a sub 3, which is negative 40 minus negative 28. So the answer is negative 12. So that is our common difference. So using again the formula, a sub n is equal to a sub 1 plus n minus 1 multiplied by d. Let us get first the given, then substitute the values of the given to the formula. Our given is a sub 1 is equal to negative 40 since negative 4 rather since it is our first term. Then n is equal to 35 since we're looking for the 35th term or a sub 35. Then d is negative 12 because our common difference is negative 12 and we're looking for a sub 35. So, substituting the values to the formula, the answer will be a sub 35 equal to negative 4 plus 35 minus 1 equal to negative 12. Multiplied by negative 12 rather. So, simplifying 35 minus 1, that is 34, then bring down the rest of the values. Then 34 times negative 12, that is negative 408 rather. Then, simplifying negative 4 minus 408, that is negative 412. So, our a sub 35 or the 35th term is negative 412. Since we already know how to get the value of a certain term, let us try this example. Which term of the arithmetic sequence is 7, 14, 21, and 28 is 224. So, from here, we're looking for what number of terms is 224. Is it the 23rd term, 24th term? So, we're looking for the value. So, the first thing that we should do is we need to find the common difference. Again, a sub 2 minus a sub 1, that is 14 minus 7. A sub 3 minus a sub 2, that is 21 minus 14. Then, a sub 4 minus a sub 3, that is 28 minus 21, which is all equal to 7. So, our common difference is 7. So, using the formula again, a sub n is equal to a sub 1 plus n minus 1 multiplied by d. Let's get first the given. Our a sub 1 or the first term is 7. Our n is the missing value since we're looking for what number of term is 224. And the d is 7, which is a common difference. And our a sub n is 224 since it is our last term. Okay? So, substituting the values from the given to the formula, that will be 224 equal to 7 plus n minus 1 multiplied by 7. So, as you notice, we're looking for the value of n, so we cannot simplify n minus 1. Therefore, we can just simply distribute 7 to n minus 1. So, that will be 7n minus 7. Since 7 times n is 7n, and 7 times negative 1 is negative 7. Then, we can simplify here. 7 minus 7, that is equal to 0. So, leaving behind 7n. And in order for us to get the value of n, we just simply divide both sides the value beside n, which is 7. So, 224 divided by 7 and 7n divided by 7. So, we need to cancel out 7, leaving n, and 224 divided by 7, that is 32. Okay, so the term of the arithmetic sequence that we're looking for 224 is the 32nd term. So, the 234 is the 32nd term of this sequence, or our a sub 32. Okay? Since we're all done with our examples, we're going to have your activity. So, in this activity, you're going to identify whether each sequence is arithmetic or not. If it is, find the common difference and solve for the 15th term. So, for number 1, we have 32, 35, and 38. For number 2, 7, 10, 13, 16. For number 3, 4, 12, 36, and 108. For number 4, we have 9, 6, and 3. For number 5, we have 1/3, 2/3, and 1. Okay? So, can you do your best? Good luck! And that's all for today. Thank you for watching! So, if you have questions, you can message me via Facebook Messenger, Abby Mendoza. Again, thank you!